Chuck, time for another explainer.
I'm all about it.
So, there's something that's been on many people's minds for a long time.
And what is that?
It is, can you get to space without using a rocket?
I had no idea this was such a pressing question.
The motivation is that, rockets are complicated and they can blow up on the launch pad, or just ask Elon.
I'm sorry.
Stop.
You know what? I never thought I'd apologize to Elon Musk, but that was uncalled for. Okay.
It's rocket science and it's hard.
And it's hard. You realize as you ascend, the time it takes to orbit Earth increases.
Pick a distance. You can do the math. Take 2 hours.
Right.
Then 3 hours.
Okay.
5 hours. 10 hours. 24 hours. 24 hours.
I'm just following one point on the Earth.
You're hovering above that point of Earth. Okay, so now if it's just hovering there, why not build a ladder?
Because there's not enough wood, and with the current tariffs that we're having, that would be too expensive.
So I'm gonna use Earth for this.
Okay.
Now I'm always uncomfortable like ripping it off its axis, but I don't do that.
'Cause you look like a really violent atlas.
So what do we have here? So the International Space Station, if Earth were this size, orbits about 1 centimeter above the surface.
Okay.
Okay, excuse me, this America 4/10 of an inch.
Okay, there you go, thank you.
Now we're on the same page.
Now we're on the same page.
Okay.
That's right.
And that's a couple hundred miles up. Geostationary orbit is 23 million miles up. The radius of the Earth is 4,000 miles, so it's that 4 gets you to the surface. Then, so now above the surface almost 6 times, 8, 12, 16, 20, 24, it's way out there.
Okay, way out here.
Okay. So now we're talking about just building a ladder.
Oh, what could go wrong?
A 23,000-mile ladder?
No one is going to ascend that, right?
You want to make it some kind of a machine that'll do this.
Okay.
Like an elevator.
Okay. Thus was born the concept of a space elevator, a cheaper, simpler way to get to geostationary orbit. And now, by cheaper, have we considered the cost of making a 23,000-mile elevator?
Here's my point. When people first came up with this idea, it was still really expensive to launch a rocket and was dangerous. And it's still dangerous, but it's not as expensive as it once was.
Correct. Getting into space today is cheaper than it has ever been, right?
And so I always questioned the utility of building an elevator to do such a thing. And when you're up there, then what are you going to do? So the idea was you would build platforms there to then continue your exploration in the solar system.
Okay. Now you're making sense, because now you don't have to launch from Earth.
It would be a spaceport. Do you realize the energy it takes you to get to Earth orbit, any Earth orbit? The energy that takes is half the energy it would take to get anywhere else in the solar system.
Oh, that makes sense, because you got to get off the planet.
Your rocket has to have enough fuel to burn after you've burned the fuel that lifted that fuel to a higher place.
I gotcha. So the rocket is mostly heavy because of the fuel, and you need enough fuel to carry that fuel.
Exactly. And it's a runaway thing, right? And that's why the astronauts are like all the way at the tip.
You just killed them.
The astronauts are like right there.
They're in there.
Okay, now here they had the lunar module in that little cylinder there, but everything else is fuel. It's just fuel. 33 stories of fuel. We can't get around the rocket equation until you can manufacture fuel at your destination. So, you have the space elevator, so you need this track that goes from the surface of the Earth up to the space elevator. So, it has to be able to hold its own weight, 23,000 miles of cable.
Okay, that's crazy.
Dangling, and it's got to hold it up. And so, it's got to be strong. Steel is not strong enough to do this.
That makes sense.
It's strong, but not under its own weight, can't do it. Well, it has to be extremely strong, but also from a molecular standpoint, very, very light. Yes. And there is one thing that has the strength-to-weight ratio. Carbon nanofibers. A few years back, a chemist discovered a new form of carbon that we had never seen before.
Are you serious?
Yeah, and it's a molecule that has 60 carbon atoms. When they analyze the structure of the 60 atoms, they're at the vertices of the surface of a sphere.
Okay.
That tracks very closely the stitching in a soccer ball.
Interesting.
It is a mixture of hexagons and pentagons on the surface. Carbon 60.
All right, so that got a Nobel Prize, a new form of carbon. But then someone said, what happens if I cut it in half and then make carbon fibers connecting these two ends? Then I can make a carbon strip.
Carbon 60.
Right? That has the strength that this original shape had, and those are called carbon nanotubes.
Right, that has the strength that this original shape had, and those are called carbon nanotubes.
Okay.
A carbon nanotube is light enough and is stronger than steel and way lighter than steel.
Of course.
that you could make a space elevator out of this stuff, and it could hold its own weight. And the last I checked, I haven't checked like lately, but the last I did check, the longest one of these we were able to make is about a centimeter.
Oh, okay, so we're on our way.
It might be longer today, but it was slow going, right? We don't have tools to just
Yeah.
to keep sewing them together. We need some process that could do it on its own. So the material is kind of still out of reach, and the idea for me still feels like we know how to get in and out of orbit.
Yeah, we do. What we need is cheaper fuel.
No, but the fuel is not even that expensive. Because the main rockets use water, right? Hydrogen, and oxygen mix them together, and it creates its exothermic. So this urge that because people were thinking of space elevators before space access became a routine thing. It was this, oh my gosh, you need special governments and agencies just to get to space. And now we got people just going up joyriding.
Right, exactly.
Right, a space elevator for it to be stationary there, it needs a counterbalance on the other side. And so it's rotating centered on the platform.
That makes sense?
Yes. So it's not only the elevator part going up, there's a whole other part that has to extend above that would be above it. And it would be tethered to that, and it would be set into rotation. So the whole system rotates once for every Earth rotation.
That's really cool.
And so that'd be an engineering marvel. And that's why it's so alluring, because it would be an incredible feat. And by the way, I have a better solution to that. It's called space rope. And yeah, you go to space, you drop a rope, come on up. And my last point about this is, do you ever wonder how long it would take to get there?
23,000 miles up, I have no idea.
Okay, so if you go 100 miles an hour, this would be a fast-ass elevator, right? Fastest elevator that ever was. Make one go 100 miles an hour. So 23,000 divided by 100 is what? 230 hours going 100 miles an hour. The 230 hours is 10 days, 24 hours a day. 230 is about...
So you'd be sitting there for 10 days.
By the way, we can get to space a lot faster.
A lot faster.
Even 200 miles an hour. Okay, it's 5 days. I mean, what you need you know what you'd have to do? Get an elevator car. That's a rocket.
So you take the rocket to the rocket and then you don't need the element.
Yeah.
Chuck solves the engineering problem.
All good, all right. So that's about all I got to say about it. Chuck, good to have you, man.
That was always a pleasure.
Been yet another Star Talk explainer, the space elevator. As always, I bid you to keep looking up. Just as a space elevator gives us a steady line from the ground to orbit, ground news offers a direct bias-aware path to understanding the world without being thrown around by ideological gravity. An independent app and website created by a former NASA engineer. Ground news applies the same precision required in orbit to how we navigate news here on Earth, giving you the common ground, what's agreed upon, what's contested, and why it matters. With ground news, I can compare how NASA, Nature, and other outlets cover the same topic, complete with data on each source's bias and reliability. I can even identify stories that might be missing from my usual news bubble, building my perspective from the full picture and not just the loudest voices. And when I want the TLDR of a major story, their daily briefings do the work for me, analyzing dozens of sources to show what's fact, what's disputed, and how different outlets are framing the issue. Best of all, Star Talk listeners can try the Premium Vantage plan, the same one we use, for just $5 a month, which is a 40% discount. Head to ground.news/staralk or scan the QR code and subscribe today.